Hi Trigoners, so these are note 6.2, right triangle trigonometry. Would you take a minute now to pause the video and read through your objectives and read through the paragraph about trigonometric ratios and SOHCAHTOA. Go ahead and do that now. All right, so this is hopefully somewhat of a review. This might have been a little confusing, this paragraph right here. So why don't we just think about, let's recall a 30, 60, 90 triangle. That was a special triangle from geometry. So we know that the sides, we have an x is opposite the 30-degree angle. X root 3 would be opposite the 60-degree angle, and 2x is opposite the 90-degree angle. So let's say we had two triangles that were similar. However, maybe one triangle was larger. We have the second triangle that's 5 times larger. So notice what we're trying to say in this paragraph is that if you take the ratio, for example, ratio of size 1 divided by root 3 and 5 divided by 5 root 3, notice that those ratios would be the same, even though the second triangle is larger, because the triangles are similar. They have the same angles. So what I would like to do next is think about, we have a triangle over here, and notice that we would say that the sine of theta is opposite over hypotenuse. So that would be B over C. And the cosine of theta would be adjacent over hypotenuse, and the tangent of theta would be opposite of it over adjacent. Now, we learned these in geometry. The reciprocal relationships then, a cosecant of theta is 1 divided by the sine of theta. The secant of theta is 1 divided by the cosine of theta, and the cotangent of theta is 1 divided by the tangent of theta. So that's why, if you wanted to find the cosecant of theta, if the sine of theta is B over C, the cosecant of theta is C over B. If the cosine of theta is A over C, the secant of theta is C over A. And if the tangent of theta is B over A, the cotangent of theta is A over B. So that's those relationships are summarized over here. So why don't we go ahead and do the first problem. So the first thing you might have done when you looked at this problem is you might have thought, oh, there's a right triangle, and you might have thought of the triples. So we have a 3, 4, 5. These are some of the famous ones, a 5, 12, 13, a 7, 24, 25, and an 8, 15, 17. These are the Pythagorean triples. Notice that the side opposite the largest angle, which would be the right angle in a right triangle, would have to be the longest side. So when you look at this one, realize this cannot be one of the Pythagorean triples because the hypotenuse is 4. And you could not have a 3, 4, 5 triangle where 5 is not the hypotenuse. Again, the side opposite the largest angle would have to be the largest side. So if I wanted to find a missing side, let's call this x, we need to use the Pythagorean theorem. So go ahead and pause the video and solve for x. All right, so hopefully you get root 7 after you use the Pythagorean theorem. So now if I want the sine of theta is opposite over hypotenuse. So opposite sine of theta would be the side that is root 7. The hypotenuse is the side with length 4, and adjacent would be next to, so that would be 3. So go ahead and pause the video and fill in all 6 trigonometric ratios. All right, so what I like to do is I like to find the sine of theta, the cosine of theta, and the tangent of theta first, and then you just take the reciprocal. So the sine of theta is opposite over hypotenuse, root 7 over 4, cosecant is the reciprocal. Then cosine of theta is adjacent over hypotenuse, and then the cosecant of theta would be the reciprocal, which is 4/3. Tangent of theta is opposite over adjacent, which would be root 7 over 3, and then take the reciprocal for the cotangent theta. Okay, so let's look at the next part, calculator evaluation. So mode is very important when you use your calculator. Notice that we should be in degree mode. We have not talked about radians yet, and there is also a radian mode on your calculator. So go ahead and pause the video and change your calculator to degree mode. All right, so here's my calculator. I went ahead and chose mode, and I noticed that I'm in radian mode, but I would like to change the degree. So again, mode is important. Whenever you use sine, cosine, or tangent, a trig function, or secant or cosecant or cotangent, we need to check our mode. Mode matters if we're using our trig function, so we need degree mode. Okay, so I need to know what is the cosine of 32. So I would do cosine of 32. There you go. And we're going to keep 4 decimal places. All right, go ahead and pause the video and find the sine of 75 degrees, the secant of 32 degrees, and the cosecant of 75. Go ahead and give it a try. All right, so let's make sure what we're really doing, because perhaps when we looked at these numbers, it didn't really mean a whole lot to us. Let's go back to this example up here, our special triangle. So if I'm looking at the 30-degree angle, and if I said, what is the tangent of 30 degrees? That tangent of 30 would be opposite over adjacent. So if I grab my calculator in degree mode and I say, tangent of 30 degrees, I get 0.57735, and you might think, well, what does that mean? But notice that 1 divided by root 3 is 0.57735. So again, these are ratios of the size of the triangle. Okay, so let's go back. So we found the cosine of 32, we found the sine of 75 degrees, but some of you might have been a little confused. What do you do when you get to the secant of 32 degrees? We don't have a secant button. Well, you don't need one, because secant of 32 degrees is 1 divided by the cosine of 32 degrees. So we could type into our calculator 1 divided by the cosine of 32 degrees. There you go. And we could type for cosecant of 75, we could find 1 divided by the sine of 75 degrees. Okay, so let's go ahead and take a look at the next 4 questions. Now, notice some of them look a little weird, but this time I'm not asking you to find the cosine or the sine of an angle. I'm asking you to find the angle itself. So we need the inverse button to do that. So let's think about it. First of all, if I say sine inverse of 1/2, for example, because notice this first one I'm saying the sine of theta is 1/2. So another way to write that would be the inverse sine of 1/2. It does not mean 1 over the sine. Okay, that's not what it means. It means find the angle. Okay. So another way to write it, you could, again, years ago, some people would write it arc sine, which is the same, means the same thing as inverse sine. Okay. So these are all saying the same thing. So we're going to grab our calculator right now, and we're going to find an angle. So to find an angle, you need the inverse button. So second sine, notice how inverse sine is above the sine button. And then you type in inverse sine of 1/2, and it's going to tell you the corresponding angle. So that would be 30 degrees, since we're in degree mode. So if it's cosecant, I would say, again, I don't have a cosecant button. So notice that the sine of theta, if the cosecant of theta is 2, the sine of theta is 1/2, because the cosecant of theta is 1 over the sine of theta. Okay, so now we know that the inverse sine of 1/2 would give us theta, which we already did that in part E, so we know that that angle is 30 degrees. So go ahead and pause the video and try G and H. All right, so if I want to find part G, I would say inverse tangent. So again, I'm looking for an angle, so I hit the inverse tangent button of 3.2, and that would be 72.65 degrees. We'll keep 2 decimal places for an angle. So notice H is a little tricky because it says arc, but again, arc is the same thing as saying inverse cotangent. Arc cotangent is inverse cotangent. So you could call this the cotangent of theta is 0.3125, but we know that the cotangent of theta is 1 over the tangent of theta. So if the cotangent of theta is 0.3125, the tangent of theta is 1 divided by 0.3125. So we'll say inverse tangent of 1 divided by 0.3125. And so you get an angle of, oh, same one, look at that, 72.65. So this is very interesting. So I wonder, is 1 divided by 3.2 is 0.3125. So that's why you got the same angle. All right, so that was great calculator practice. So now that we know about SOHCAHTOA and trig ratios, and we also know about how to use our calculator, how to find a missing side, how to find a missing angle. So what we're going to do now is we're going to solve a right triangle. So for number 3, I'm looking at the figure, and it says use the figure and a calculator to solve for x using cosine, and then they want me to solve for x using sine. So for example, if I'm looking at this angle, I could say the cosine of 40 degrees is adjacent over hypotenuse. So go ahead and pause the video and use your calculator and find the measure of x. So if you type this into your calculator, 10 divided by the cosine of 40 degrees is 13.05. However, we know that, let's try to do this a different way. Notice that all of the angles of a triangle add to 180, so that means that we could find the measure of this third angle would have to be 50 degrees, because 50 plus 40 plus 90 is 180. So you could have also said the sine of 50 degrees is opposite, which would be 10 over hypotenuse. So go ahead and pause the video, use your calculator, do 10 divided by the sine of 50 degrees in degree mode, and find x. There you go. So we found x two different ways. 10 divided by the sine of 50, 10 divided by the cosine of 40, 13.05. All right, so that was good calculator practice. Why don't we go ahead and take a look at number 4. So notice that you are given a right triangle and you are given 2 sides. So you need to solve the triangle, which means find all of the missing sides and angles. Now, first of all, I should show you this, that traditionally we use a capital letter for an angle, and we use a lowercase letter for a side measure. So opposite angle A would be side A. Opposite angle C would be side C, and opposite angle B would be side B. Okay? You can't just put the letters anywhere you want. Opposite A, angle A would be side A, opposite C is side C, etc. So go ahead and pause the video and see if you can find the missing sides and angles. Well, I noticed that this is a Pythagorean triple, 5, 12, 13. If you did not notice that, you could have said 5 squared plus c squared equals 13 squared, and you would have come up with 12. So C, side C, is 12. And now if you wanted to find some angles, you could say that, for example, the cosine of angle C is adjacent over hypotenuse. So since you're trying to find the measure of an angle, you would need to use the inverse. The cosine inverse of 5 divided by 13 would be angle C. So go ahead and pause the video and find angle C. All right, I did the second to get the inverse cosine. Notice it's in blue above the cosine feature there. So if I do inverse cosine of 5 divided by 13, you get 67.38 degrees. And we know that that angle A and angle C are complementary. They must add to 90. So you could find angle A. So that angle A is 22.62 degrees. So we solved the triangle. We found the missing information. All right, so the last part of our notes, we are going to look at applications. So for all of these, we would need to read the problem. We would have to try and draw some type of picture, and then go ahead and answer the question. So go ahead and pause the video, see if you can draw a picture that would describe number 5. Okay, so if this is a right triangle, the legs are the sides that are not the hypotenuse. The hypotenuse is opposite the right angle. So if we wanted to, we could use tangent, because tangent would be opposite and adjacent. So we want to find the tangent. That we need to find, so the tangent of theta is actually 2, so we need to use the inverse to find the angle. The inverse tangent of 2 is 63.43 degrees. Please pause the video for number 6 and see if you can draw a picture. Okay, so now if we're trying to find angle theta, we would need to think about which trig function is most helpful here. So notice opposite theta and hypotenuse. So that would be sine. Sine of theta is opposite over hypotenuse. So go ahead and grab your calculator and find angle theta. Remember, to find an angle, a missing angle, you need the inverse feature. Make sure you're in degree mode and do inverse sine of 22 divided by 30. Okay, so for number 7, it might be kind of tricky to draw a picture for this one. let's just get started. It says that Diane looks up to Helene, so this must be Helene, and this must be Diane, with an angle of elevation of 32 degrees. So let's just talk about angle of elevation. So notice if this is Diane and she is looking up to Helene, the angle of elevation is from the horizon and then it would be to the line that connects Diane to Helene. So this would be the angle of elevation. Now notice it says that Diane walks closer to the building. So this is Diane at the first sighting, this is Diane at the second sighting, and it says Helene is 30 feet from Diane. So again, if I want to know how far they are, it's like they're holding a string, so they're 30 feet from each other. So this distance right here is 30 feet. And it says this time Helene looks to Diane with an angle of depression. So let's talk about angle of depression. Angle of depression is from the horizon down. So you might think, well, Mrs. Corbett, why are you putting the 40-degree angle here? Well, let me explain. Remember from geometry, we talked about how alternate interior angles, horizon lines, are parallel. So notice that these are alternate interior angles because we have a transversal that is intersecting two parallel lines. So that would be, if this is the angle of depression right here, you could also put the 40-degree angle right here. Those angles would be congruent. Okay, so they want to know a lot of things. They want to know how tall is the building? How far is Diane from Helene at the first sightings? They also want to know why. So why don't we go ahead and start with this right triangle. So I'll make this a different color. You could only use SOHCAHTOA if you have a right triangle. So you could say that the sine of 40 degrees, because this is opposite and hypotenuse, if we're using with respect to the 40-degree angle, is x over 30. So go ahead and pause the video and grab your calculator and find 30 times the sine of 40. Okay, hopefully you have 19.28 feet. Okay, so notice the yellow triangle is also a right triangle. So now we are trying to find y. So we have sine of 32, at 32 degrees in the large yellow triangles. We could use sine again because 19.28 and y would be the opposite and the hypotenuse for that particular triangle. So y is 36.38 feet. Okay, let's take a look at number 8. See if you could pause the video and draw a picture to describe number 8. All right, so we have a flagpole. This would be the flagpole right here. That's a flag. Notice at 3 p.m., I don't know if that's really very important, but we know that we have a 12-foot shadow and that the angle of elevation is 58 degrees, and we're trying to find x, the height of the flagpole. Okay, so you have to figure out which trig function would be most helpful. Go ahead and pause the video and write an equation to solve for x. Hopefully you chose tangent. The tangent of 58 degrees is x over 12. So we use our calculator. X is 19.2 feet. Okay, so here's the last one we're going to do, and we're going to actually have you finish the rest of these for part of your homework. So let's take a look at number 9. Go ahead and try and draw a picture. Okay, so here they're trying to find the measure of the acute angle between the line and the x-axis. So notice we had a positive y-intercept and a negative slope, so it helps to find the x and y-intercepts. So now you know that we have a right triangle, and if you wanted to find this angle theta, that would be opposite over adjacent, so that would be tangent. You would need tangent of theta is opposite over adjacent. If you grab your calculator and you do inverse tangent of 10 divided by 10/3, you will get angle theta. So go ahead and pause the video and find angle theta. So hopefully you have 71.57 degrees. Great job, everybody.